Hello, welcome. Let's try to solve another Leetcode problem 923, threesome with multiplicity. Uh, so yeah, for this problem we are giving an integer array and an integer target. So we're gonna return the number of tuples I, j, k such that I gonna be less than j and less than k, and array I plus array j and plus array k should equal to the target. As the answer can be really large, so we're gonna have a final modular. Yeah. So the mod gonna be 10 to the power of 9 plus 7. Yeah. So if we are going to check some values, it's gonna be really big. So for example, 10 to the power of 9 plus 7. So this means basically we're gonna need to use dynamic programming to solve the problem. Normally the DFS with memorization should be easier to solve. Yeah. So we're going to prepare a case and we're going to use the DFS to solve the problem. Yeah. And what we're going to return? We're going to return. So as there are going to be three numbers, so we're going to prepare a counter. We're going to prepare the index, and the second value going to be the target, and the third value going to be the so the index target and the third value gonna be the we're gonna prepare a counter. So the third value gonna be the counter because we only need to have three numbers which gonna equal to target. Yeah. So similarly inside I'm gonna prepare the index and yeah, I'm gonna prepare a target maybe t, and I'm gonna prepare a counter. So in which condition it is a valid answer? So for example, 1 plus 2 plus 5, definitely it's going to be a valid answer. Yeah. So yeah. So this t is the target. Yeah. So if t yeah, I'm gonna check I equal to n. So if the index goes to the end, goes out of the array, it means I need to return answer. I'm gonna return 1 if t equal to the target and the count equal to 3. Else, it means it is not valid. I'm gonna return a 0. Yeah. Now, yeah, so this is the edge case. If I equal to n, definitely I'm gonna check it if it is possible or not. Yeah, if it is possible, this t must equal to the target and the count must equal to 3. So otherwise, I'm gonna have two decisions. I can choose this number or not. So first of all, I will not choose this number. So it's gonna be I plus 1 and t and count. And secondly, I will choose this number. So it means from the t gonna plus this number. So it's gonna be array I, and the count gonna plus 1. Yeah. So this is the basic pattern. Let me just run it to check. Yeah. So this n gonna be length of the array. Let me put it here. Yeah. So basically, I'm going to count all the possible cases. This is just like brute force. I'm going to check all the cases, and I just need to use a case with memorization to solve the problem. Yeah. Now let me just submit it to check if it works. Yeah, because it is too big, as we can see, the output is too big. Definitely, we need to use a modular. So finally, we need to modular this mod. Yeah. Now let me put it inside and yeah, run it. And now this testing case works. Let me just submit it to check. But it didn't work. Yeah, so this time the memory exceeded. Maybe we're gonna try to use some other ways to save the memory. So we're gonna set the result gonna equal to this one, and result dot we're gonna use a cast clear, and And finally, I'm going to return the result. I think it is the DFS. It is this function dot clear, and then I'm going to return the result. Now let me just run it. Yeah, it is still the memory exceeded. This means yes, we cannot use this solution to solve it. So now, what about we just add some edge cases to check? Yeah, because currently we just need for this I, it has to be equal to n. So what about we just prepare some cases to let the branch stop immediately? So for example, the train can be really big. Yeah, so what about at this branch we can stop it immediately, so the train gonna become smaller. So in this way, maybe we can solve the problem. Yeah. Now let's just solve it like this way. So if the count is more than 3, or t is more than target, so definitely it's not possible. So I'm gonna return a 0. So currently I'm gonna use this tag. Yeah, maybe I can speed up a little bit. Yeah, now as you can see, this time it works, but it's really slow. But because it is a dynamic programming, basically it works. But let's analyze the time complexity first before we analyze once more. So the time complexity is going to be this 3000 times 300, because the target is going to be 300. Yeah, so it's going to be a really big number, and we're going to also times this count going to be 3. It seems that it's going to be 10 to the power of 6. That is why it's a little bit slow. Yeah, so we can still optimize a little bit. So we're gonna sort the array, and we're gonna set reverse equal to true. So in this way, we can stop the recursive function earlier, because we're gonna sort it according to the biggest number. If the biggest number, for example, this 5 plus 5 is gonna be more than the target, definitely we're gonna stop it. We're gonna check all other cases. Yeah. Now let me just run it and submit it to check if it works. Yeah, as you can see, this time it works. It's nearly 3 seconds, but I think it's okay for this problem. Definitely we solved it by using DFS with memorization. Thanks for watching. See you next time.